Hello friends, now we take one example of homogeneous linear differential equation of third order. This is the homogeneous linear differential equation of third order. You can see that this can be written as s cube dqy by dx cube minus 2x square d2y by dx2 plus 8x dy by dx minus 8y is equal to 10 times x plus 1 upon x whole square. You know that this is the third order homogeneous linear differential equation with this is the third order homogeneous linear differential equation. Now we convert this linear differential equation. Now we reduced this into linear differential equation with constant coefficient. For finding this, we put x equal to e to the power z, and in place of s cube dqy by dx cube, we put here d minus 1 d minus 2 y. In place of x square d2y by dx2, we put d minus 1y, and in place of x dy by dx, we put here dy, where capital D is equal to d by dz. When we convert the homogeneous linear differential equation into linear differential equation with constant coefficient, always we put x equal to e to the power z. In place of s cube dqy by dx cube, we put d minus 1 d minus 2 y. In place of x square d2y by dx2, we put d minus 1 y. In place of x dy by dx, we put dy. So above equation converted into linear differential equation with constant coefficient. You can see that this can be written as d minus 1 d minus 2y, and here 2, and in place of x square d2y by dx2, we put here d minus 1y, and in place of x dy by dx, we put here dy minus 8y is equal to 10, and in place of x we put here e to the power z, and in place of 1 upon x we put here e to the power minus z whole square. Now this can be also written as d square minus 3d plus 2 minus 2d square minus d plus 8d minus 8 times y is equal to 10 e to the power 2z plus e to the power minus 2z plus 2. Here we expand this a using a plus b whole square, we get a square, that is e to the power 2z, plus b square, that is e to the power minus 2z, plus 2 times a multiplied by b. So we get 2 here. Now you can see here this can be also written as d cube minus 3d square plus 2d minus 2d square plus 2d plus 8d minus 8 times y is equal to 10 times e to the power 2z plus e to the power minus 2z plus 2. So we solving this, so we get here this can be also written as d cube, here minus 3d square minus 2d square minus 5d square plus 2d, this is plus 4d and plus 8d, this is 12d, and here this is minus 8 times y is equal to 10 times e to the power 2z plus e to the power minus 2z plus 2. So now we find the, now we can write this d cube minus 5d square plus 12d minus 8 times y is equal to 10 times e to the power 2z plus e to the power minus 2z and plus 2. So this is the linear differential equation in with constant coefficients. Now this is reduced into third order linear differential equation with constant coefficient. This is linear differential equation with constant coefficients. Now we find the solution. First we find here auxiliary equation. So for forming auxiliary equation we replace m in place of d. So this is m cube minus 5m square plus 12m minus 8 equal to 0. This is the cubic equation in m. Now we find the roots of this auxiliary equation. So we know that here m minus 1 is the factor of this, because when we put here 1, so we get this is equal to 1 cube, this is 1 minus 5 plus 12 minus 8, so this is 13 minus 13 is equal to 0 equal to 0. So m minus 1 is the factor, m minus 1 is the factor. So we write here m minus 1 and m minus 1 3 times. We multiply this m by m square because we have to make here m cube. So this is m square multiplied by m, we get m cube, and m square multiplied by minus 1 we get minus m square. Here this is minus 5m square, so we write here minus 4m. Minus 4m multiplied by m we get minus 4m square, and this minus m square we get minus 5m square. This minus 4m multiplied by minus 1 we get plus 4m. Here we have to make 12m, so we multiply 8 here. So 8m plus 4m, this is 12m. Now we taking common m minus 1. So this will be m square minus 4m plus 8, this is equal to 0. Now we factorize this. So use here Sridhar formula and get the roots of this quadratic equation. So m is equal to minus b plus minus under root b square minus 4ac divided by 2a. So m is equal to 4 plus minus here 16 minus 32 upon 2. This is 4 plus minus minus 16 upon 2. So this can be written as 4 plus minus, this is 4i divided by 2, this is 2 plus minus 2i. So this is the solution of, this is the roots of the auxiliary. Now we write the complementary function of the above linear differential equation with constant coefficient. So you can see here this is alpha plus minus I beta, so alpha is 2 and beta is also 2. So the complementary function can be written as c1 times e to the power m1x plus c, here you can see that e to the power alpha x, c2 times cos beta x plus c3 times sin beta x. So this is the complementary function. Here you can see this is m1 is equal to 1 here. So e to the power x, and alpha is 2 here. So e to the power 2x. Here we write, this is z, because we convert here this differential equation into the variable z. So the complementary function of the above linear differential equation with constant coefficient is c1 times e to the power m1z plus e to the power alpha z times c2 cos beta z plus c3 times beta z. Here m1 is equal to 1, so we get c1 e to the power z, and alpha is 2 here, so we get e to the power 2z, and c2 cos beta is also 2, so this is 2z plus c3 sin 2z. Now we convert this e to the power z in place of x. We know that when we convert homogeneous linear differential equation into linear differential equation with constant coefficient, we put x equal to e to the power z. Now we convert this e to the power z into x, so we write here c1x, and this can be written as e to the power z whole square, so this can be written as x square, and c2 cos 2, and z is here, you know that z is here log x, z is here log x or ln x plus c3 sin ln x. You can see, because we put, when we convert the given homogeneous linear differential equation with linear differential equation with constant coefficient, so we put x is equal to e to the power z, so we taking log, we get z, so z is equal to ln x. You can write z is equal to ln x. So this is the complementary function here. This is the complementary function sin 2 ln x. Now you find the particular integral. So for finding particular integral, we write here 1 upon ft, 1 upon d cube minus 5d square plus 12d minus 8 times 10 e to the power 2z plus e to the power minus 2z and plus 2. Now this can be also written as 10 1 upon d cube minus 5d square plus 12d times minus 8 times e to the power 2z plus 1 upon d cube minus 5d square plus 12d minus 8 times e to the power minus 2z plus 1 upon d cube minus 5d square plus 12d minus 8 times 2 e to the power 0z. Because e to the power 0z, this is equal to 1. Now you know that when we find the particular integral of e to the power ax, when we find the particular integral of e to the power ax, always we replace a in place of d, where fa can never be 0. So when we find the particular integral of e to the power z 2z, we replace t in place, we replace 2 in place of d, and we replace minus 2 in place of d here, and we replace 0 in place of d here. So you can see here, when we replace 2, we get, now we put 2 in place of d, we get the particular integral of e to the power 2z. So 2 here, 2 cube minus 5 2 square plus 12 multiplied by 2 minus 8 times e to the power 2z plus 1 upon, here we write minus 2 cube minus 5 minus 2 square plus 12 minus 2 minus 8 times e to the power minus 2z. And in the third term, we replace 0 in place of d, so this is now we simplify this and get the particular integral of linear differential equation with constant coefficients. Now we will simplify and get the particular integral 10, and here you can write 2 cube, this is 8 minus 2 square 4, 4 5 are 20, and plus 12 to the 24 minus 8 times e to the power 2z plus 1 upon minus 2 cube, this is minus 8, and minus 2 square, this is 4 multiplied by 5, this is 20, and minus 2 multiplied by 12, we get minus 24 and minus 8 times e to the power minus 2z, and 1 upon 0 cube, this is 0, and 0 square, this is 0 multiplied by 5, 0, 12 multiplied by 0, 0, so we get here minus 8 and 2 e to the power 0z. So this can be written as, this is 24 minus 20, this is 4, and this 8 is cancelled out, so here is 1 by 4 e to the power 2z. Here this 20, 24, this is 44, 20 and 24, this is 44, and 8, 8, this is 16, 44 and 16, this is minus 60, and e to the power minus 2z, and here we write minus 8 2 times e to the power 0z. So this can be written as 1 upon 4 e to the power 2z plus minus minus 1 upon 60 e to the power minus 2z, and here 2 4 is 8, 1 by 4 times e to the power 0z, this is 1. Now we multiply this 10, so we get 2 to the 4, 2 5 is 10, so this is 5 by 2 e to the power 2z, 10 6 is 60, so 1 upon 6 e to the power minus 2z, and here 5 2 5 is 10, 2 2 is 4, this is 5 by 2. Now this can be also written as 5 by 2 times e to the power z whole square minus 1 by 6 e to the power minus z whole square and minus 5 by 2. So we put here x in place of e to the power z, this is 5 by 2x square minus 1 by 6, here we write 1 upon x whole square, this is minus 5 by 2. So this can be written as 5 by 2 x square minus 1 by 6 x square minus 5 by 2. So this is the particular integral. Now if we find the solution of the given homogeneous linear differential equation, this can be written as y is equal to complementary function plus particular integral. So the complementary function is c1x plus x squared times c2 cos 2 ln x plus c3 sin 2 ln x plus 5x square divided by 2 minus 1 upon 6x square minus 5 divided by 2. So this is the general solution of the given homogeneous linear differential equation. Thank you.